All right, the margin of error. Now you may hear this on, when you're listening to the news, because you all listen. They always say something like 50% of the people believe this, plus or minus 3%. And that is what we're talking about when we talk the margin of error. It means we take a sampling and we find the mean of that sampling and the standard deviation, and then we say, okay, if I were going to say this is the whole world, the entire population, it's not going to be exactly this number that I get, the same mean, the same standard deviation, but it's going to be close. How close? And that's what the margin of error and the confidence interval is all about. It's talking about this normal curve that we have, margin of error being how our sample that we have differs from an actual population. And the confidence interval is using that margin of error to create an interval that might include the entire population. So let's do a couple of examples. These are just basic examples, not a whole lot of real life meaning for these two particular ones. But you'll get the idea of just how to do it. The next one kind of gives you more of an idea of real applications to this. So if we're given the sample mean and the sample standard deviation, we can see how this projects to the real world, to the population, by using these. So the margin of error is always 2 times our standard deviation. So here the standard deviation, so we'll call it the margin of error, is 2 times the standard deviation, which would be 30. So that means if our mean was 100 and we sampled the entire population, our confidence interval will be 100 plus 30 for the max and 100 minus 30 for the min. So if our mean was, 100, then the real world, everyone else, if we sample anyone else in the real world, their average would be somewhere between 70 and 130. And that's just taking it so that we can see how this projects to an entire population instead of actually taking the sample from the entire population, which would be impossible. So that's what statistics are for. So same deal with this one. We have a standard deviation of 0.463. So what we have to do is we have to multiply that by 2. Well, okay, go Bears. 0.463 times 2. So that would be 0.926. Yeah. And then we add to figure out what the entire population would fall in between, or at least the mean would fall in between. And that would be 0.926. We're going to add that to the mean. And if I do this, I get 1.741. And then I take that mean again, and I subtract 0.926. That's the margin of error, and I get negative 0.111. So the confidence interval, the 95% of the population that would fall, the average would fall somewhere between negative 0.111 and positive 1.741. Sometimes the standard deviation is not found. Sorry, I forgot the T there. The standard deviation isn't accessible to us. So what we get is we get some sort of proportion or percent that an event was successful. And we try to project it to say, would that be successful in an entire population? So this is the formula that you use. It's a bit messed up, but you got to remember it and try it out. P is the people in the event divided by the total people. So that's always a fraction or a decimal. Often they give it to you as a percent, and you have to change it to a decimal. N is the total number of people sampled. And then we just have this awesome little formula that you have to use. After we've done that, that is the margin of error. And then we just take that sample proportion and add or subtract it, just like we did on the other one. But in our case, it was just the mean. Here it's the sample proportion. So it's sample mean proportion, that's just what it's called. Okay. So when you look at this problem, they tried to figure out how many teenagers between 13 and 18 have a TV in their bedroom. So they surveyed 1,432 people and students or whatever, teenagers, and they found that 630 of them have a TV in their room. So what is the sample proportion? So that's just how many people are in the event. This is your P that's above there. How many people are in the event divided by the total number of people. So this is how many people were successful, meaning how many people actually had a TV in their room, and this is the total number of people that actually were asked. So when I do this, I find it's 0.4399 repeating. So the nearest tenth of percent, remember you multiply that by 100, and you get 44.0% if we round that, because that, moved it over to this, and you have to round and put that 0.0. Now the next one is find the margin of error. So that's that nasty little formula up there. The margin of error is the square root. It's 2 times the square root of P times 1 minus P over N. So 2 times P. That's this number, but it has to be a decimal, or this number. So we're going to use 0.44. It has to be the converted version, or non-percent. It has to be that decimal. And then we do 1 minus that same thing, and we divide it by the total number of people. So that was 1432. Doing this, I have it here somewhere, 2.6%, or I actually get 0.0262348,653. But they want it as a percent, so I have to multiply this by 100, and I get 2.6%. So that is our margin of error, 2.6%. Determine the range of the population that will contain 95% of the data. So what we're saying is, if I were to survey any town in the whole United States, so if I were to go to Selden, we're not going to say that 44% of the students would have, or 44% of the people that you know would have a TV in your room, because there is a margin of error. So around what percent would people have a TV in their room? Okay, so let's do this. So the max would be 44% plus the margin of error. So that would be 46.6. That's the max number of students. We wouldn't have half, but we could have close. And the min percent of students would be 44% minus 2.6. And that would be approximately 41.4%. So the range would be between 41.4% and, I don't know what that thing's there for, 46.6%. So if they asked you to write that as a decimal, you could write it as a decimal. Here we're writing it as a percent, because that's what the rest of them had you do. So let's say Selden has 5,000 teenagers. How many teenagers could we expect to have TV in their room? So the percent is 41.4 and 46.6. So how many is that? So we're going to find the range. So we just, 41.4%, and we multiply that times 5,000, and that turns out to be, that's the low end. So this is the min, so it's 2,070, and then the high is 46.6. So if I'm trying to find how many people, I have to divide that by the percentage by 100 first, multiply that by 5,000, and I get 2,330. So approximately somewhere between 2,070 and 2,330, we can be really confident that somewhere in there, if there's 5,000 teenagers in Selden, that this many are going to have TVs in their room. Somewhere between there. All right, have a good day.